So when it comes to rotational mechanics, everything is analogous. So velocity is analogous to angular velocity. Momentum is equal to, it's analogous to momentum angular. Mass is analogous to moment of inertia. It's just angular mass. Acceleration is analogous to alpha or angular acceleration. What else do we have here? Force is analogous to torque, which is just the angular version. These are all the angular version of each other. So yeah, any equation you have with terms of kinematics, you can just replace the analogous values and you get the same thing. Oh yeah, distance. Distance, or S, is analogous to theta, because any change in S is a change in theta, because it's now in terms of arc lengths. So if you're in the middle here, your distance is no longer a linear path, it's the arc length. So this part right here is known as the arc length. And that's kind of proportionate to the change in the angle. You could say that it's in terms of radians, rads, or degrees, doesn't matter. It's really it. I mean, they're all the same. So then here, work is usually the integral of force and the change in position. Position is now in terms of theta. Could you have three-dimensional? If it was a sphere, I guess you could have three-dimensional theta. But then you're not really rotating uniform way, I guess. You'd be, how can we derive? I guess the important things you need to know is that these things, angular acceleration is the change in work, the change in omega over the change in time. There you go. Okay, yeah, there's not much to derive from there, but from chemistry, thermodynamics, this is where it gets insane. Okay, we'll begin with the probability. So what you should know is the Boltzmann distribution equation. Probability in terms of velocity is equal to 4 pi times 1 over 2 pi m over kt v squared times e to the negative m over kt v, I think. mv squared over kt. kt. There you go. So for us to actually get these three equations, RMS, average, and MP, you need to be a bit smart. So here, not smart, but smart with how you do it. So here, we can say that M is constant, K is constant, temperature is constant, leaving us with V being variable. So again, that's reiterated here. Probability is a function of velocity, which means that if you want the max point, this means for us is that if we graph this equation, we'd have some point that's the maximum value, where the derivative, or the change in v over the change in time, probability over the change in velocity, is 0, which means the derivative in terms of velocity going to be equal to the derivative of this whole function. So d of dv of 4 pi 1 over 2 pi mkt to the 2/3 v squared e to the negative m 2kt v squared. Okay, what does that mean for us? For us, this entire term is a constant. So I'm going to say, okay, let 4 pi over 1 over 2 pi m over kt 2/3 equal to, we'll say, every letter is used in physics. I can't even, gamma, to just be stupid because every other letter is used. d over dv. And since constants can come out in terms of differentiating, we can do this. V squared e to the negative, okay. And we can also say let negative m over 2kt equal to, let's take another stupid, beta v squared. There you go. Now if we differentiate this, we get that gamma times, it'll be, so it'll be left d right, the derivative right is 2 beta e to the beta v squared, beta v, oh, we can also take out e to the beta v squared. We get that's 2, nope, beta v plus 2v, I guess, or yeah, plus 1. So now let's look at every term. This term cannot equal 0, it's a constant. V, sure, can equal 0, but is that really like an actual practical answer? No. Velocity being 0, sure, yeah, that's when our derivative is 0. That really has no practical use case for us. The graph of an exponential is never 0, so e to the beta v squared is never 0. It approaches 0, so we can write it like this, but it's never actually 0. Now let's take a look at this. Beta v plus 1 has to equal 0. What does that mean for us? V has to equal negative 1 over beta. Yeah, okay, there you go, yeah, it works. Negative 1 over, and then beta we wrote as negative m over 2kt. So now these guys cancel out, and we get that this is equal to 2kt over m. Here when I was differentiating, this should have been 2 beta v. There you go. So this should have been v squared, v squared, v squared. There you go. So we get that v squared is equal to 2kt over m, and that's v. And we get a special denotation. V maximum point is equal to 2kt over m. So again, we have the function p v is equal to 4 pi 1 over 2 pi m over kt 2/3 v squared e to the negative m v squared. Now we want to integrate this. So how do we do that? Well, if we integrate pv in terms of dv, I'm gonna ignore every single constant. Here we get that's the integral of v squared e to the negative m over 2kt. Now what we can do here is, given this equation, let's look at the formula sheet for something similar. We have a squared term and then e to the some squared term. So here the formula sheet tells us that the integral from 0 to positive infinity, negative infinity does not make sense to us. Negative velocity relative to what has no meaning for us, because this is all relative to some non-moving point. If it's negative infinity, it's moving away from us. Again, this graph always functions from 0 to infinity, so negative infinity makes no sense to us. So that's where the upper and lower bounds come from. The integral of this term of some variable squared times e to the negative ax squared in terms of that variable is 1/4 of the square root of pi over a cube. How does it help us? Here we can recognize that's pretty similar. If you like to make it look exactly like that, you can say let v equal x. Of course, dv equals to dx if you really want to make that variable change. There you go. You can also say let a equal negative, just positive, m over 2kt. So then from there, this transforms into the integral of x squared e to the negative a. Of course, this was once in terms of dv. So then we get, this is 1/4 pi over a cubed. Since a is this term, this is just equal to 1 over 4 pi over m 2kt. Now you can leave it like this or simplify. Let's simplify. 1/4 square root pi times a cubed over square root of 8 does not exist, so we can just write it like 1 over 4 pi times kt over m cubed. How do they have it written? Did we use the wrong formula? No, it's the right formula. Something should have been cubed, but nothing is cubed in there.